Hi, this is Mrs. Doris, and this is Lesson 6-4 entitled Applications of Linear Systems. The objective is that you will be able to apply systems of equations to solve word problems. And this is a great example of where we use systems of equations to solve real-life type problems. And you'll be solving many of these in the coming days. Today our notes are only going to take us through problem number 2 in your notes. The best method to use to solve a system of linear equations depends on the form of the given equations and how precise you want the solution to be. The three methods that we have, and we have already talked about this to some extent, are graphing, substitution, and elimination. Graphing is the best one to use if you want a visual display of the equation. It is also good if you want to estimate a solution. And of course, graphing is easiest if it's in slope-intercept form, but you can always make a table of x and y values and graph at any time. Substitution is the second method, and this one is best to use when one equation is already solved for one of the variables or when it is easy to solve for one of the variables. And the only time that it would really be easy to solve for one of the variables is if a variable in an equation has a coefficient of 1. If it has a coefficient of any other number, I don't recommend using substitution because frequently when you solve for the variable, you can end up with fractions in your equation, which makes it very difficult to solve. Elimination is the method to use when it's not convenient to use the other two. Elimination is very quick and easy if the coefficients of one variable are the same. For instance, you have a 2x in one equation and a negative 2x in the other equation. Or if they're both 2x, then you can subtract and eliminate that variable. All right, problem 1. Finding a break-even point. Oh, and also in your notes there is a statement that systems of equations are good to use, or useful, for modeling problems involving, to fill in the blanks, it would be mixtures, rates, and break-even points. And that's what we're going to do in our first problem. Finding a break-even point. Break-even is when your expenses and your income are the same. So you're not losing money, but you're not making money. That's why they call it break-even. A puzzle expert wrote a new Sudoku puzzle book. His initial costs are $864. Binding and packaging each book cost 80 cents. The price of the book is $2. How many copies must be sold to break even? All right, your first step in solving any word problem is to define your variables. So, for instance, what are the two things that we don't know? Well, the first one is how many copies must be sold. So let's use C to represent the number of copies. And then the other thing, which is a little more subtle but that we don't know, is what the total is. What is the total when expenses are the same as income? So we'll just put T for the total. All right, so let's write one equation for the expenses, total expenses, and we'll write one equation for the total income. All right, so T, our total, would be equal to, all right, well, looking up above, we are told that his initial costs are $864, okay, and that binding, Excuse me. All right, sorry for the interruption. We were writing an equation for expenses. So we are told that binding and packaging each book cost 80 cents. So added on to our initial cost would be 80 cents or 0.8 for each copy. So 8 tenths times C. For income, we are told that the price of the book is $2. So our total income is going to be $2 times the number of copies sold. Now, this is a good example where we already have a variable isolated, the variable t. So we're going to use substitution by taking t equals 2c and substituting the 2c in for the t in the first equation. So what we have is 2c equals 864 plus 0.8c. All right. The first thing that we have to do when we have the variable on the left and on the right is to get them on the same side of the equation. So I'm going to remove it from the right side by subtracting 8 tenths c. Okay? It cancels out on the right side. On the left side, 2c minus 8 tenths c would be 1 and 2 tenths c. On the right side, all we have left is 864. Then divide by 1 and 2 tenths, and we get c is equal to all right, we'll shove that out of the way. 864 divided by 1.2 is 720 copies. All right, so the question is, what does this mean? Well, it means that you have to sell 720 copies of the Sudoku puzzle book in order to pay all of your costs, and then if you don't sell this many, you're going to be losing money. If you sell more than 720, that's where you begin to make your profit. All right, let's go to the next problem, which is very similar to this. Printing a newsletter costs $1.50 per copy plus $4.50 in printer's fees. The copies are sold for $3 each. How many copies of the newsletter must be sold to break even? This is very, very similar to the other. Again, we could use C for copies, or how about let's change it. Let's use N for the number of newsletters. All right, and then again, we need to know the total cost. We can use T for total. All right, so, and that would be total money or cost. All right, so again, we're going to write an equation for the expenses. So our total expenses would be the $4.50 in printer's fees. Oops, no decimal point there, sorry. $4.50 plus $1.50, and I can drop the zero, so 1 5/10 times the number of copies, or in this case we're using N for newsletters. All right, our income equation, again, is going to be our total, and they're sold for $3 each, so I have 3 times the number of newsletters. So once again, we're going to take our 3n, since it's equal to t, and substitute it in for the t in the first equation. So that would give us 3n equals 450 plus 1.5 N. All right, again, getting our variable on the same side, we're going to subtract 1.5 N from each side, 1 5/10, I should say. It cancels out on the right. 3n minus 1 5/10 n is 1 5/10 n is equal to 450. Divide both sides now by 1 5/10, and we get n is equal to 300 newsletters. So in order to pay all of our expenses, we need to sell 300 newsletters. Anything we sell over that then will give us income. All right, so what is the relationship between income and expenses before a break-even point is reached? Well, our expenses are greater than the income. Okay, so we are losing money, which is not a good thing. All right. What is the relationship between income and expenses after a break-even point is reached? Well, that's when our income exceeds or is greater than. Income exceeds expenses. So we are making a profit. All right. We're also going to look at problem 2, identifying constraints and viable solutions. And then at the end of this problem, you'll see more problems in your notes, but we'll tackle those on another day. All right, viable solutions. The word viable means that it is possible. It makes sense to the problem. So, once you solve an equation, you need to consider the viability of the solution. A solution that has a negative number of hours is not a viable solution. If you're finding the length of something and you get a negative number does not make any sense when you're talking about the length of an object. All right, so here is our problem that we're faced with. The zoo has 2 water tanks that are leaking. One tank contains 10 gallons of water and is leaking at a constant rate of 2 gallons per hour. The second tank contains 6 gallons of water and is leaking at a constant rate of 4 gallons per hour. When will the tanks have the same amount of water? All right, well, let's identify the 2 things that we don't know. This question right here gives us one clue, when. Well, when is what time, and all of our time in this problem is in hours. So let's use H for the number of hours. And the other thing that we don't know is the amount of water, when it will be the same. So since our amount of water is in gallons, let's use G. And that will be for the gallons of water in the tank. And this would be at any given time. All right, so we're going to write one equation based upon one tank, and we'll write our other equation based on the second tank. All right, so let me move this out of the way to give us room to work. All right, so one tank, we are told. The gallons of water in the tank, G. Um, Oops, let me use red since I underlined that first tank in red. All right, here we go. G equals. We're told that it contains 10 gallons of water. And it's leaking, meaning that it's losing so I'm going to subtract at the rate of 2 gallons per hour. So that would be 2 times the number of hours, H. My second tank, we'll put in green, the second tank contains 6 gallons of water. And again, it's leaking, which means I'm going to subtract water from it at the rate of 4 gallons per hour. So 4 times H. All right, so my question is, when will the tanks have the same amount of water? All right, well again, because we have the variable isolated, I'm going to take this expression and substitute it over here. So I have 6 minus 4H is equal to 10 minus 2H. All right. I have the variable on both sides, so I can choose which side that I want to move it to. I've got a minus 4 over here, so I'm going to add 4H to both sides. That will give me then a positive rate of hours. So what we end up with on the left is 6. On the right-hand side, we have 10 minus 2H plus 4H would be a plus 2H. All right, subtract 10 from each side. 6 minus 10 is negative 4. 10 minus 10 is 0. 0 plus 2H is 2H. And then divide by 2. Negative 4 divided by 2 is negative 2 equals H. Now, hours being a negative number, this is considered not a viable solution because we're going backwards in time. Now, you could make an argument for this. And if we were finding length, then I would definitely put not a viable solution. You could make an argument. If the tanks held water more than what we're told they currently contain in this problem, then you could look at this problem that perhaps 2 hours ago, 2 hours before they were discovered to be leaking, they would have had the same amount of water in the tank. So if you want to look at it that way, you can. It may not make sense if they're 10-gallon tanks to start with. So keep that in mind as well. So basically they would say, because we have a negative number of hours, that it is not a viable solution. All right, so we're going to end our video at this point and your notes. There is a worksheet number 1 that I would like you to try. They will not all be in this format. You may use substitution or you may need to use elimination on these problems. I would like for you to take a look at them, define your variable. In fact, let's review those procedures that you should do in writing a system of equations. To solve a word problem, using systems, the very first thing that you need to do is to identify and define variables for the two, and there could be more than that, but all we will be dealing with is two unknowns. And I'll put two unknown quantities. All right, and that's just a matter of choosing what you want them to represent. Like, for instance, we chose C to be the number of copies and T to be our total money. Okay, so that's what I mean by define. Step 2 is to write two equations. Now, writing the two equations, in the examples in today's lesson, we wrote one for expenses, one for income. In another example, if we were trying to figure out how many cows and chickens, it might be an equation for the number of heads and an equation for the number of legs. In another example, we might be trying to find the number of adults and the number of children. So we might have, let's say, the number of adults and number of children that went to Disney World on a single day. So we might have an equation for the adult cost and the children's cost, and we might have an equation based upon the number of adults and children that attended that day. So this is going to take some practice and just experience in different types of word problems. And then, of course, once you write your two equations, you're going to be doing what we did in the first 3 lessons. Decide on a method to solve the problem. And on our word problems, you're going to be using substitution or elimination as one of those two methods. We generally will not be graphing these. All right, decide on a method to solve the problem and solve it. And then, of course, your last step, but very important, is to check your solution. Always check it in both equations to make sure that it works in both equations, and make sure that the answer is a viable one that makes sense to the problem. For instance, if you're finding the number of people, you shouldn't have a fraction. You can't have a fractional number of people. So always check your solution and then make sure it's viable. All right, thank you very much, and I'll see you in class.